Hello everyone, this is a problem from magnetism chapter. It said that two long state wire at a separation D 16 cm carry current I1 is 3.16 milliampere and the I2 is 3 times of I1. Both the current are out of the base, so that's mean over here out of the screen. Now where on the x-axis the net magnetic field equal to the 0 due to this current into these two wire. And the second question, if the two current are double, is a zero field point shifted towards the wire 1, shifted towards the wire 2, or it will remain unchanged. It means that if we change the current on the wire 1 and 2, so if I make the double of the current in wire 1, then the zero field point will be shifted towards the wire 1 or shifted towards the wire 2, or it will be remain unchanged. Let's start. We know that from Biot-Savart law that the magnetic field for a long straight wire could be write down. It should be, I'm writing the magnitude, B would be mu naught into I into twice pi r, where r is the distances. So this is your wire, long straight wire. From that wire at a distance, you are finding at a distance r, you are finding magnetic field. The strength of that magnetic field we can find out using that formula. Fine. Now in this problem we have to find out the direction of these two magnetic field, and we are assumed that at point over here, say the magnetic field is 0. Say this is that distance from wire 1, say that x. Fine. Now the direction of this magnetic field at that point due to current I1 into the wire 1, it would be towards that upward. So this is would be the direction of magnetic field by the current 1. So that's why I write down the B1. And for the current in wire 2, the magnetic field must be towards that downward direction. This would be that B2. You can find out that direction. You can find out the direction of the magnetic field, right? Put your thumb in the direction of the wire and rotate your rest of the finger around the wire. The direction of your rest of your finger at every point will give you the direction of your magnetic field. So that's why the current into the wire 1 is out of the phase. So that's why magnetic field at the location of that point will be towards the upward, and the magnetic field for current I2, it will be towards the downward direction. Fine. Now these two magnetic field is going to be cancel out each other at that point. We assume that, right? So then we can write down, say that B1, magnitude of V1 must be equal to the magnitude of B2. Then the B1 we can write, say mu naught I1 divided by twice pi x. X is the distance from wire 1 to that point, must be equal to B2, which would be the mu naught I2 divided by twice pi d minus x, right? Since they give me the distance between these two wires is the d, that is x, then that distance is going to be basically d minus x. Now we can plug in the value of that. We can cancel out this mu naught. We can also cancel out these twice pi from both sides. We'll find out that I1 divided by x must be equal to I2 divided by d minus x. Now I2 basically 3 times of I1, right? That given into the question. So over here, so this is actually I2 actually the 3 times of I1. So I'm going to plug in that value. So I1 by x must be I2 would be 3 into I1 divided by d minus x. Now we can also cancel out this I1 from both sides. Then we will find out d minus, sorry, you can write d minus x would be thrice x, or 4x would be basically d. Now the d is given, which is actually that 16 centimeter. We can write that is actually that 16 centimeter, or 16 into 10 to the minus 2 meter. Then x would be 4 into 10 to the minus 2 meter, or equal to 4 centimeter. So that's mean from wire 1, 4 centimeter away from that wire 1, two magnetic field is going to be cancel out each other. So this is actually answer number A. Now the question number B, they ask you if we increase the current or double actually both two wires. So that's mean if I increase the current, make the current double in wire 1, it will automatically make it the double in wire 2, since I2 actually the thrice of I1. So if I make the double of current in wire 1, then the zero field point will be shifted towards the wire 1, shifted towards the wire 2, or it will remain unchanged. So now we can say from there, this is the last part of this question over here, which is independent of that current I, right? This part. Now we can find out that one from that part of this equation, because in the some part we find out that this equation become I1 divided by x equal to I2 divided by d minus x, right? We find out that thing over here. Now this thing, if we make the double of the current into that wire, so this is would be 2 I1 divided by x equal to 2 I2 divided by d minus x, right? So if I make the double, it's going to be the 2 I1, but I2 actually the 3 I1, so this would be basically then 6 I1 divided by d minus x. Over here would be basically that x. Now we can find out that it would be I1 will be cancel out, it will remain the same equation, basically 1 over x would be basically 3 by d minus x. That's again become actually d minus x, actually that thrice x, or we can write it would be 4x would be basically d, which is exactly that same one. So that's mean that point would be the remain unchanged, or x equal to, you can say that d by 4, it will be the remain same. So that's why if you make the current double into that wire, the zero field point is not going to be the change. That's the answer of this question B. Okay, thank you very much.